reactions in the lab. These reactions are really cool because we're able to see chemistry in action. But the best part about doing reactions in the lab is that we are then able to write the balanced chemical equations for these reactions. This is really important because it helps us to understand what's happening at the molecular level from what we saw in the laboratory. But when we're writing chemical equations, we need to know a couple of rules first. These include, we need to decide what type of reaction we're dealing with. Is it a double replacement reaction where both reactants switch to form two separate products? Or is it just a single replacement reaction where one switches to form a separate product on the other side of the reaction? We also need to decide if it's a precipitation reaction where a precipitate is forming, or if the reaction favors complex ion formation, where a precipitate is dissolving and a complex ion is forming. Once we figure out what type of reaction we're dealing with, we then need to remember the rules for what does not separate in a balanced chemical equation. Things that do not separate include states, which are solid, liquids, or gases, complex ions, or polyatomic ions. Pretty much everything else is going to separate when writing a balanced chemical equation. Now that we know the basic rules, we are now ready to actually write and practice our balanced chemical equation writing skills. Here's an example of a reaction that took place in the lab. We added potassium chromate, K2CrO4, to barium nitrate, BaNO3,2. When we added these two things together, which were both aqueous at that point in time, it formed a yellow precipitate. So we know that this is a precipitate reaction, and because of that, we also know that this is a double replacement reaction, which means that both of these things are going to switch places with each other to form two separate products. So to do this, we draw our arrow, showing that the reaction is happening. We're going to have barium switch and be with the chromate, BaCrO4, plus potassium nitrate. Okay. When we do this, we know the barium chromate has to be the solid that forms because our solubility rules tell us that barium is a solid and will not dissolve. So we're going to add an S here, which means that this has to be aqueous. We also know that from our solubility rules because potassium, whatever it is paired with, is always aqueous and will always dissolve. This reaction looks like it could be complete, but not quite because we're not exactly balanced. Over here, we have two potassiums and two nitrates, but we only have one of each over here. So in order to fix this problem, we'll just add a 2 for potassium nitrate. That gives us both a 2 of potassium and also the nitrate, which will give us a balanced chemical equation over here. The next step in writing a balanced chemical equation is figuring out what the balanced ionic equation should be. In order to do this, we have to decide which things from our balanced chemical equation are going to separate and which things are going to stay together. Remember from the beginning, we talked about certain things that will separate throughout an equation. Our first thing we're going to look at is our potassium chromate. Potassium chromate will separate, but not completely. Our chromate here is a covalently bonded molecule. So while our potassium will separate into 2K+, because potassium has 1 plus charge, our chromate is going to separate into CrO4-. It is important in your balanced ionic equation to also include the states of everything involved. The next step is the barium. This will also separate. Barium has a 2 plus charge. Our nitrate, however, is a polyatomic ion, so it will not separate. But we have 2 of those because nitrate has a minus charge of 1. Okay? So this gives us our reactant side of the equation, and then we can switch over here and write our product side of the equation. Now barium chromate was our solid precipitate that formed. Because it is solid, it will stay together in our balanced ionic equation. It will look just like it does above. Our potassium nitrate, however, will separate into 2K+ and 2NO3-. Write our states here, and there we have it. That is our balanced ionic equation for our equation above. very last step in writing a balanced chemical equation goes with writing the net ionic equation. In order to do this, we simply cross out things that appear on both the reactant side and the product side in the exact same way. This is because things that appear in both sides are spectator ions, and they are not actually participating in the reaction that we're interested in. So our net ionic equation just includes the parts of the equation that actually play the part in the reaction. So in this reaction, we can cross out the potassiums and the nitrates, which will leave us with our chromate, CrO4 minus, plus our barium, Ba2 plus, for the things on our reactant side. And on our product side, we just have our solid that form barium chromate. And that is how you write a balanced chemical equation with all three steps. All three parts are important because they all tell us a little bit different things about the reaction. The first one is everything that takes place in the reaction that's in the test tube while the reaction is occurring. The balanced ionic equation shows us how they appear in solution, and the balanced net ionic equation shows us just the things that play a part in the actual reaction. Knowing this helps us to gain a better understanding on the molecular level of what we saw happening in the lab. Now you know how to write a balanced chemical equation, and hopefully this will help you in the future as you write more complicated equations.